The other thing we're going to look at is the surface area of a cylinder. And with a cylinder, so first of all, what a cylinder is, it's similar to a a prism where it has the two bases, but for a cylinder, the bases are circles. And then you have basically a rectangle wrapped around it. So if you're trying to visualize how there's a rectangle wrapped around it, think about a can of soup. Okay, that shape is a rectangle. But what happens if you take that can of soup and you take the label on the can of soup, cut it from the top to the bottom, and then unwrap the label? If you unwrap that label, you'll see that it forms a rectangle. Okay? And so again, thinking about the idea of unwrapping, that's the idea of a net. So the net of a cylinder looks like this. You have a rectangle, that's that unwrapped rectangular lateral side. And then you end up with a circle on top and bottom. You could also think about what would happen if you tried to cut open a pop can and flatten it out. First thing you'd have to do is you'd have to cut the base on the top and the bottom, and then cut from the top and the bottom. And if you flattened it all out, it would look something like this. All right, so now we need a way to find the surface area of that. You'll first notice that part of the surfaces are your top and your bottom, two circles. And then thinking to the last chapter and what we've done in the past, how do you find the area of a circle? Pi times the radius squared. But in this case, there are two of them. So you start with the top and the bottom, and that's 2 times pi times the radius squared. Pi r squared is one top, and then the other top would also be pi r squared. Since there's two of them, you double it. Okay, so then what we have to do is we have to find the area of that wraparound, that rectangular lateral side. So like the label of our soup can. Okay, and when you unwrap it, you'll figure out that it forms a rectangle. So how do we find the area of a rectangle? We multiply the base, the length, times the width or the height, whatever you want to call it. This part of your rectangle is going to be whatever the height of that cylinder is. So whatever the height of your cylinder is, that is the height of the rectangle that would have to wrap around the cylinder. Okay, so now we just need to figure out how long that part is. And if you visualize that that has to wrap around, if we were to try and fold this back up, has to go around this whole piece right here. Okay, in other words, has to go around the edge of the circle, also known as the circumference. So if you go over here to this part of your formula, the length of that rectangle has to be the same as the circumference of the circle, because when you fold this up, your rectangle has to wrap around your circle. Okay, so how do you find the circumference of a circle? We've done that already this year. 2 times pi times the radius. And then times by the height. So this part is your area of the lateral, and when we say the word lateral, it means the part that goes around, the part on the side of a prism or a cylinder. Or all right, so now let's go ahead and try and find our surface area now that we know what the formula is. So you are wrapping a stack of 20 CDs using shrink wrap. Each disc is cylindrical with a height of 1.2 millimeters and a radius of 60 millimeters. So let's say you're stacking up your CDs to get rid of them because everything's on your phone now. So you've got, if you stack them all up, one CD does form a very, very short cylinder. Now when you stack them up, it would form a slightly bigger cylinder. So we're stacking 20 CDs on top of each other. One CD has a radius of 60, so the stack would still have a radius of 60. Now, when you stack 20 CDs up that are each 1.2 inches or millimeters high, to find the actual height, it's actually going to be 24.0 millimeters high. So that being said, we can go ahead and find our surface area using our formula, which again is 2. So we start with the area of our bases. So pi times the radius squared times 2. So our radius is 60. Okay, so we start with our radius is 60, so we can put our radius in there, our radius in there. Our height we said was the 24 millimeters, so we plug in those numbers. And it's up to you, depending on the type of calculator you are and how comfortable you feel with your calculator. You can type all of this in at once. Another option that you can do with these is you can do what we say leaving it in terms of pi. So basically you kind of treat the pi as like an x and you leave that in your answer. And so here I would take 60 squared, so 60 times 60, which would give me 3,600, and then if I times that by 2, that gives me 7,200. So this part right here is 7,200 pi. Okay, so I multiplied everything together except for the pi part. Here I would have 2 times 60, which is 120, and 120 times 24, don't have my calculator in front of me, so I'll do that real quick. Should give us, I believe, 2,880. So we end up with 7,200 pi plus 2,880 pi, which can be combined together to give us 10,080 pi. And so you can leave your answer like that. Okay, so that's one option of a way that you can leave your answer. 10,080 pi. Okay, and then that's your answer. You leave it in that, and then it would be, we're talking area. So one thing about surface area is, even though we're talking about a three-dimensional shape, we're still talking about area, so our units is still squared. And the unit in this case is millimeters, so our units is going to be millimeters squared. Okay, so you have two options. You can leave your answer like this, or like I said, even back at this step right here, you could just leave your answer, or you could just type this whole thing into your calculator and put your answer as 31,667. Okay. So you can leave your answer like this, or you can leave your answer like this. All right, both of these answers are correct. Whichever way you prefer to write them is fine. All right, so now we're going to do a little bit of working backwards, and you can see in this case, they left it. Now this one, when it's left in terms of pi, will actually make these working backwards problems really easy. Okay, all right, so we want to find the height of a right cylinder shown, which has a surface area of 50 pi square meters. So we've done problems like this where we have to work backwards. We've done problems where we're given the area. In this case, we're given the surface area. And so we start with, it's a cylinder, we start with the surface area formula. And we plug in the information that we know. So for the surface area, I know it's 50 pi. The radius I know is 2.5, so I plug that in where I have it. Now, this instance, we want to try and solve for this h. So first thing we have to do is we have to try and get this term over to the other side. But in order to do that, we want to do a little bit of simplification first. And you could take everything with the pi and multiply it, multiply by 3.14 and deal with it that way. That's fine. But if you leave it in terms of pi, it actually makes it really easy to do without any decimals, without having to deal with any decimals. So here I've got 2.5 squared, which is 6.25, and multiply by 2 is 12.5. Okay, so we have 50 pi equals 12.5 pi for this term. And then here we have 2 times 2.5, which is 5. So this would be 5 pi h. All right, so then what we can do, now this is a more simplified term, and we can go ahead and move this term to the other side, because this is the term with the h that we're trying to get by itself. All right, so now the one thing is when you're working with the pi, you can work with it the same way as you would with an x. So these are like terms. 50 pi minus 12.5 pi is so 50 pi minus 12.5 pi gives you 37.5 pi. And then we still have the 5 pi h over here. So then what we can do is we can divide both sides by 5 pi. And this is where it's nice to have that, because the pi's will cancel out. If you have something times pi and then you turn around and divide it by pi, it just cancels out. And so then you just end up with 37.5 divided by 5. And you get 7.5 for your height.